everyone. I'm Aggeliki Stathopoulou. I'm a civil engineer and a certified passive house designer. I direct Net Zero. It's a company that designs and constructs passive houses, mainly in Greece. Also, I'm an ILFI ambassador and collaborative in Greece. So I'm here to present a crosswalk that took place, the alignment between two standards, Passive Houses Institute certification and International Living Future Institute certification, Net Zero Energy. And here I must say that partnering for energy efficient buildings is very important, and here will now be presented all this work done, which is there to provide clarification on how to navigate the different metrics that are included in these standards. So starting from passive house and EnerFit standards, we have a key thermal and envelope target, both for new and for retrofitted buildings. And this all leads to substantial reductions in the overall energy consumption, building energy consumption. So in order to meet the zero energy requirements, all this energy remaining for consumption must be met with measured renewable energy generation. We have requirements, specific energy efficiency requirements for passive house certification, and this provides a targeted pathway which is focused on obviously high energy efficiency in order to pursue for zero energy. And on the other hand, we have the 12-month performance requirements of zero energy certification, and this actually provides the mechanism to validate all this anticipated energy saving that is the outcome of a passive house design and construction, and of course certification. So these are the main reasons why ILFI and PHI find these two certification programs to be highly complementary. I will start with a few words about how ILFI Zero Energy Certification came up. So it evolved out of the Living Building Challenge, the LBC that Alex previously described, which was released in 2006, and actually set a new benchmark on green building because it needed and required a holistic and proven performance. So the Zero Energy Certification Program was then developed in 2011, followed a similar structure than the energy petal, and it set a streamlined target for a net zero annual balance of energy consumed and generated. So in 2017, we had a revision, and it was done in order to meet all non-energy requirements and focusing exclusively on this energy balance. This certification recognizes all projects that demonstrate the highest levels of energy performance and also spur creation of renewable energy sources. We need 100% of the building's energy needs on a net annual basis that must be supplied by on-site renewable energy. And the certification is based on actual performance. It's measured, and it's achieved, is validated after a 12-month performance period. About passive house and EnerFit standards, the International Passive House Standard was launched in 1966 in Germany, after following the construction and monitoring of the first pilot project, Passive House Pilot Project in Darmstadt in 1991. We have thousands of examples that are being built all around the world and prove that the passive house delivers the objectives, no matter the climate, no matter the shape, the size, the typology, and the scale of the building. So on this graph, you see some monitoring that took place of passive houses, and it shows that the actual measured energy consumptions for the heating, in this case, the energy consumption for heating are very, very close to the expected ones by the design, which is very important to know that we can have actual results and know what to expect. So in general, passive house buildings consume up to 90% less for heating and about 80% less cooling energy demands than typical existing buildings, of course, depending on climate. We have a tool we use for passive house design. It's Passive House Planning Package, the PHPP. With it, we optimize, of course, the building's design. We have on-site quality assurance measures. One of the main parts of passive house is airtightness. So, of course, we do tests to prove that we have the airtightness that we keep in mind and we consider on our design. So we have airtightness measurement. And in overall, there are buildings that provide healthy and high-quality living and working conditions. It is based on the laws of physics, and the methodology is applicable worldwide, both for new and existing buildings. Besides the passive house and EnerPHit classic standards, all buildings that incorporate renewable energy generation and have a higher overall efficiency, of course, can aim for the plus or premium classes, both for new and retrofitted buildings. And here you see a snapshot of PHPP. It's from the PER worksheet, and you can see how everything is calculated. So we know what is our demand, we know what we generate, and we have the annual balance. So when this number is zero or positive, negative, it means that we produce as much as we consume or even more. And I will refer to this snapshot in my presentation at several points while presenting the crosswalk to you. So let's start with this crosswalk. We have an alignment on 11 different sectors. The project scope, combustion and energy uses included in the energy balance, concerning the project scope in general. Then we have the energy demand limits by end use. We have the building envelope, the total energy demand, the total energy generation, the zero energy balance, which are the performance requirements. And then we have the compliance and documentations, which means the predictive modeling, metering, and final verification. And now we will see snapshots from this document, and we will discuss separately. So starting from the project scope, we have requirements from passive house. On the first column, you see what are the 11 different scopes. And then on the second column, we see the requirements of a passive house for plus or premium. Next follows zero energy certification requirements and then the alignment. So if we start from project scope, we see that for passive house, the requirements is the entire building. So we need an entire building in order to talk about passive house. Several limited exceptions might be for some phased retrofits or pilot projects. On the other hand, zero energy certification doesn't necessarily need a total entire building, but the new buildings can obviously limit down to a part of the building where the ownership, the funding, and of course the operation are distinct from the rest of the building. And of course, the area to be certified must be physically and visibly distinguishable. So aligning these two, we see that the whole building compliance for passive house is compatible with zero energy certification. Moving on to combustion, it is permitted in a passive house, so we can have a passive house with a stove or an airtight, of course, stove or fireplace. It is not permitted in zero energy requirements and specifications. So very limited exemptions, but with restrictions. So in order to be eligible, these two, we need to have houses that are not using combustion, do not include combustion, with the limited exceptions I mentioned. Moving on to energy uses included in the energy balance. For the passive house, we have all the energy uses within the thermal envelope. And for zero energy, we have all equipments and energy using systems related to any part of the building, including process energy. Exception is the electrical vehicle charging that is not included. So for the alignment of the two, they are mainly compatible. Compatibility for specific projects should be verified. And at the end of my presentation, you will see who you contact and where for any verifications needed. We move to the performance requirements. So as far as energy demand, limits by end use, we have limits in passive house requirements. We need the minimum useful heating demand and heating load required, and also the useful cooling and dehumidification demand and cooling load. On the contrary, no limits are specified for heating and cooling for zero energy certification for the demand. We need the total site energy use measurement from a utility or a private meter that must be reported over a 12-month period. So in this case, having a very low energy limit of passive house is an advantage in order to reach this balance that we need for zero energy certification. I move on to building envelope. We have requirements of air tightness in passive houses, and also we have some supplementary criteria regarding some minimum thermal properties to ensure that we have comfort and hygiene. But building envelope for low performance requirement are not specified for zero energy certification. So between the two, we have for sure an airtight building is expected at least to reduce the overall energy use that we measure for the zero energy certification over the 12-month period. For the total energy demand, we have requirements set for passive house, and we talk about the total renewable primary energy. Includes the conversion factors from site to renewable energy, primary energy, to account all the grid sourcing of energy, meaning all the losses of transmission, conversion, and storage through the way. We have no limits specified for overall energy demand. Once again, I say that the projects are monitored, and we have the 12-month period that we need to know that the building has consumed less or equal to the energy that has been generated on site. So we have a little different approach on this part as far as the compliance metrics for these two standards. But as I showed you before in this snapshot, and I mentioned I will use it on the way, having these numbers on PHPP can help us predict what is the amount of energy to be generated on site in order for someone to reach the zero energy certification, which is important. For the total energy generation, in passive houses, renewable energy is done with reference to the building footprint, the footprint area of the building, yes, for plus and premium certifications. We count both on-site and off-site renewable generation. It is accepted, both cases. Renewable energy generation must be additional, not something existing, not already existing. And renewable energy is defined as photovoltaics, solar thermal, wind turbines, water-powered microturbine. Coming to zero energy certification requirements, we don't have a minimum renewable energy generation demand. The same applies. We have the measured for the 12-month period that we take in account and we need. All the renewables must be on-site, so it's slightly different from passive house. Off-site renewables can be permitted in limited circumstances. So once again, like passive house, renewable energy generation must be additional and not already existing. And here we have a slightly different way of defining renewable energy. which is defined as passive solar, photovoltaics, solar thermal, wind turbines, water-powered microturbines, direct geothermal or fuel cells powered by hydrogen generated from renewable powdered electrolysis. So nuclear energy is not considered to be renewable, and of course not our combustion-based sources. So the two standards here we see that have some different approach to the compliant metrics, but we can know that in annual site energy generation reported in the PHPP, as I already showed and said, can be used to predict potential achievement of zero energy when compared to estimates of annual energy demand on PHPP. And we have a slight difference, as I said, in the definition of renewables for the two standards. Going now to zero energy balance, this is not specified, not required in a passive house. Energy demand and energy generation have independent targets. For zero energy, net energy balance of site energy use and energy generation over 12 consecutive months must be 0 or better. So the two standards here take different approach once again, but having this access to these numbers in PHP worksheet, we can see if we have a 0 or a negative number, that for sure we will, it's predicted that we can achieve the zero energy certification. It means that we actually generate more than what we consume. So in order to summarize, sorry, I jumped one. Okay. Perfect. So for the compliance and documentations, for the predictive modeling, in PHPP we use, in Passive House we use PHPP, which is the Passive House Planning Package. It's a tool in order to optimize our design. And recommended by Passive House is the submission for pre-certification, highly recommended. For ILFI, we have narrative of design methodology, which is required, but energy modeling and is not reviewed and required as part of the certification documentation. And the alignment between the two gives us the why, because zero energy compliance is based on measured performance. So having the modeling data that will lead us to do that is not required for submitting for the certification. And having the PHP modeling, we can know and predict whether we can aim for a zero energy certification or not. Metering in Passive House, it's not required. In zero energy certification, we need either utility or private meters installed in order to directly measure or permit to calculate the consumption and generation separately. So net meters are not sufficient. We need two different systems. So meter showing one-time annual energy generation consumption is required for zero energy and not required for Passive House. And for the final verification, for the Passive House standards, we need to have our PHPP calculations, all the respective project documentation required. We need the pressurization test, as I mentioned before. And we also, since we have a mechanical ventilation with heat recovery, we need to have the flow rate adjustment on site. So this comes together with ventilation commissioning that is submitted. And of course, we have a lot of building site documentation. For ILFI, building site documentations are required in photographs, etc., design drawings, system schematics, and narratives. And of course, we need to have the measurement, the performance, a 12-month performance period, the total energy used data for that. So in case of zero energy certification, Passive Houses must be, they need to be equipped with two separate utility or private meters and submit this consecutive 12 months of use. in order to verify for zero energy compliance. No site visit from any auditor is required for both. So summarizing down, we see that Passive House and EnerFit certifications have a rigorous requirement for airtightness and modeled energy efficiency in order to assure that we will have a comfortable, future-proof, and buildings that provide good air quality at low expense. And these are strategies that are appropriate in order to achieve the zero energy certification, but these are not set as specific requirements for these metrics. So we keep in mind that if we are targeting for a zero energy certification of a passive house, we need to know that there is no combustion permitted, main difference of the two, and we need to equip this passive house with separate utility meters or private meters in order to permit the measurement and calculation of the total annual generation and consumption balance. On the other hand, the 12-month performance requirements of zero energy come and provide a mechanism to validate the outcome and anticipated energy savings from a passive house. If targeting for a passive house certification of a zero energy building, we keep in mind the differences we saw together on the building scope, the entire building or part of it, the air tightness, which is very important because this is already decided and designed from early stage of design. There will be a need to complete and submit the PHPP model and all the supplementary drawings and documentations required. And of course, we will need to have both the ventilation commissioning, adjustment of our ventilation system, and the result of the blow door test, which is as prescribed for the air tightness of our building. For any contact and inquiries, these are the two institutes with a contact, so you directly contact them in case you have any inquiries about certifying a project, either with zero energy certification or passive house certification. I would like to mention the contributors, of course, of this page that I presented, this crosswalk. So from Passive House, it's Camille Sifferlen and Jessica Grove-Smith. And from the International Living Future Institute, it's Patsy Hisley and Andrew Lee. It's the job we discussed today. I have some references here. Some links that might be very useful in order for you, firstly, to download this crosswalk. There's much more information that you can have and details and explanations on things. And it can be very useful if you are thinking about going with either one of the two standards. And of course, you will see some extra links that show all the documentation needed in order to certify in a passive house and all these extra and supplementary things I told you about that we need to have to submit in order to go for the specification. The last link is monitoring. Interesting to see. It's research on PHPP modeled versus measured energy. So I think there's a lot of things that you can look up and see there. So that's about all from me. I would like to thank you very much for your attention, and I hope you enjoyed.